Salam and hi everyone. In this video, I want to show how to solve this problem. A 40 milliampere current is carried by a uniformly wound A core solenoid with 450 turns and its diameter is 15 millimeter and the length is 12 cm. Calculate A. The magnetic field inside the solenoid. B. The magnetic flux through each turn of the coil. C. The inductance of solenoid. And D. If current were different, which of these quantities would be changed? Okay, we move to the question A. Calculate the magnetic field inside the solenoid. Firstly, the symbol of the magnetic field is capital letter B. And to find the magnetic field, we have formula B equal to micronaught and I, where micronaught is a constant value, N is number of turn of the coil divided by the length of the solenoid, and I is current. So substitute the value. Micronaught is 4 pi exponent negative 7 times with N, which is number of turn 450 divided by the length 0.120 times with current, which is 0.040. Press the calculator and we will get the value of the magnetic field is 1.88 exponent negative 4. I need the answer in micro unit, so convert it into 188 micro. And the unit of the magnetic field is Tesla, which is capital letter T. So the total magnetic field inside the solenoid is 188 micro Tesla. Okay, we move to the question B. Calculate the magnetic flux through each turn of the coil. Firstly, the symbol of the magnetic flux is phi. And to find the magnetic flux, we have formula phi equal to B times A, where B is the magnetic field and A is the area of the solenoid. Because of solenoid is circular, A will be equal to pi r square. So substitute the value. B is the magnetic field that we have done the calculation, which is 188 micro Tesla, times with A, which is pi r square. From the information given, the diameter of the solenoid is 15 millimeter, so the radius will be equal to 7.5 exponent negative 3. Press the calculator and we will get the value of the magnetic flux through each turn is 3.33 exponent negative 8, and the unit of the magnetic flux is Tesla times meter square. Okay, we move to the question C. Calculate the inductance of the solenoid. Firstly, the symbol of the inductance is capital letter L. And to find the inductance of the solenoid, we have formula L equal to N phi divided by I, where N is the number of turn of the coil, phi is the magnetic flux, and I is current. So substitute the value. N, number of turn, 450 times with phi, the magnetic flux that we have done the calculation, which is 3.33 exponent negative 8 divided by I, current, which is 0.040. Press the calculator and we will get the value of the inductance is 0.3747 exponent negative 3, which is 0.3747 milli. and unit of the inductance is Henry, which is capital letter H. Okay, we move to the last question. If the current were different, which of these quantities would be changed? As can be seen in the three definitions and their respective formulas, both the inductance, the magnetic flux, and the magnetic field would be affected and will be changed if the current were different.